These are the solutions to 2024's AS2 mathematics exam. This is a mechanics and statistics paper. So first of all, if we read the instructions, it tells you answers should be given to 3 sig figs, and also gravity should be taken as 9.8 meters per second squared. Okay, question 1 says, a particle of mass 6 is moving under the action of constant force F newtons. At time t equals 0, the velocity of p is 6I minus 5j. When 8 seconds later, so when t equals 8, p has a velocity of 14I minus 21j. Find the acceleration in the form a vector I plus b vector j. So your initial velocity is this thing. I'm going to write it as a column vector, so 6 minus 5. Your time is equal to 8, because 8 seconds later. And your final velocity is going to be this, as a column vector, is 14 minus 21. And what we need to find then is your acceleration. So we can just use vector v is equal to vector u plus vector a times t. So that's going to be 14 minus 21 is equal to 6 minus 5 plus then it's going to be 8 times a. So bring that 6 across. 14 minus 6 is just going to be 8. Bring the minus 5 across, becomes plus 5. Minus 21 plus 5 gives you minus 16. And that's equal to 8a. So divide through by 8. You're going to get your a is equal to 1 minus 2, which is an I minus 2j. And that's going to be meters per second squared. The next part of the question says, find the magnitude and direction of F. Let me just look a wee second. See, your mass is 6, and you know your A is I minus 2j. So let me just write that down before I forget it. My mass is 6, and my A worked out to be 1I minus 2j. So F, you need to find the magnitude and direction of F. So find F, first of all. It's equal to M times A, which in this case is 6 times that is going to be 6 times minus 6 minus 12. And I'm just going to write that as 6I minus 12j. So I've just written that, yeah. Okay, so that's what we've got. You draw your diagram then, right angle triangle. Believe it or not, that's meant to be a right angle triangle. That's 6 and then minus 12. So obviously not even drawing the scale. And the modulus of F would be the diagonal. And theta there, you can see we've got that. So theta, to find it, tan, this is my opposite over adjacent. So it's going to be just 12 over 6. Theta then to 3 sig figs is 63.4 degrees to 3 sig figs. Your F, your modulus of F is, sorry, and that should just say is below the horizontal. You've got a diagram, but just put that below horizontal in just to be sure of getting the marks. Your F then is equal to 6 squared plus 12 squared, square root of that, and that works out to 3 sig figs. I got 13.4 newtons to 3 sig figs. Next question. This question says, Adam and Ben are competing in a cycle race. They're both sitting on their bikes at the starting line of a horizontal racetrack with the finish line 100 meters away. At time t equals 0, Adam starts from rest and accelerates uniformly for 4 seconds to a maximum velocity of 10. Then maintains his velocity until he crosses the finish line. Time t equals 0, Ben starts from rest and accelerates uniformly at 2 meters per second squared until he crosses the line. Sketch the time for Adam. So this is Adam here, this bit. Or sketch a VT graph for Adam, I should say. So your sketch, you've got your velocity, you've got your time, and Adam, it says he gets up to, accelerates, and starts from rest and accelerates uniformly for 4 seconds to get a maximum velocity of 10. So 4 seconds, he gets up to 10, and then he maintains this, and that's it. So there's Adam. Okay, and that's all you had to do for that one. So the next part of the question says, determine who wins the race. So we've got Adam, and we've got Ben, was it? So for Adam, the distance here, this is a time we want to find, but the distance for this whole thing, this whole trapezium shape, is 100 meters. So I'll just say for Adam then, the distance is equal to area under the graph. So if you look at this, this is a trapezium. The parallel sides, one of the parallel sides is, well, sorry, they'll do the easy one first. This parallel side is t, this one then is t minus 4, and the perpendicular distance between them is 10. So a trapezium, remember your trapezium rule, it's a half a plus b, where a and b are parallel sides, and h is a perpendicular distance between them. So the area was 100 meters, and that was a half, and then t plus t minus 4, the perpendicular distance between them was 10. Let's tidy up. That's 100 is equal to 5 times 2t minus 4, which means 100 is equal to 10t minus 20. 120 is equal to 10t. Wee bit of working out. Your t is equal for Adam, 12 seconds. Okay, for Ben, it tells you in the question for Ben, where's Ben's bit? You could use a graph here, but I will just use the Suvat equations. Ben starts from rest, so u is equal to 0, a is 2, and he's got 100 meters. So you've got your u is 0, your a is 2, and s is 100. I would just do that. So, but plenty of you will use a triangle just. Absolutely fine to do that. S equals ut plus a half at squared. Works out really nicely. 100 then is equal to 0 times t. And then a half times 2 times t squared is just t squared. So t then equals this positive square root because it's time, 10 seconds. Okay, Ben finishes in 10 seconds. Adam takes 12. Question says, who wins? So your answer is Ben wins. Okay, what's question 1? 3. Lovely. Okay. Box of mass 10 kilograms rests on a rough inclined plane, 30 degrees to horizontal. Why is this not coming on? Okay, there we are. Technical difficulties. Don't know why that's not going there. Okay, right. Box of mass 10 kilograms rests on a rough horizontal plane at 30 degrees to horizontal. The box is held in equilibrium, so it's held static, by a light and extensible string which makes an angle of 20 degrees with the plane. So that's going to be a tension in that one. The box is on the point of slipping down the plane. So if it's going to slip down, that means friction has to act upwards. So going up this way, you're going to have your friction. Tells you the coefficient of friction is 0.4. So that's 0.4R. And you've got your normal reaction. Try and do that at right angles to your plane. Not the easiest thing to do, but at right angles to your plane, and continue that wee line on along. And then you're going to have your mass, which is 10g going down, and this angle in here is also 30 degrees. That's all you've got. So find the tension in the string. Okay, if we go horizontally, you've got this force going horizontally, a certain amount of your t going horizontally, and the component of the weight going, it's not horizontally, sorry, parallel to a plane, I should have said. So that's what you would have. So we're going to have to find you're going parallel to your plane, it involves the r, the 0.4r. So we're going to have to find that r first of all. We're trying to. So we're going to resolve perpendicular to your plane. So going perpendicular to the plane. So that, when I say that, I mean going in this direction and in this direction. Going perpendicular plane. Clearly I've got an r. I've also got t sine 20, and that equals my 10g cos 30. So I can rearrange that, get r is equal to then 10g cos 30 minus t sine 20. Going to resolve parallel to, it's in equilibrium, so there's no acceleration. So the force, now that we're going parallel to a plane, so now I'm going to look at the forces going up a plane. And I've got two of them. I've got my 0.4r and also a component of the t, and also I've got the component of the weight going down the plane. So going up the plane, I've got t cos 20 plus 0.4r, and then going down the plane, I have 10g sine 30. So for this one, what I could do is sub this one into the second equation. So that now becomes t cos 20 plus 0.4 times my r, which was 10g cos 30 minus, that's a t, minus t sine 20 is equal to 10g sine 30. Now what to do is just multiply that out. That's going to be t cos 20. 0.4 times 10 is just going to be 4g cos 30 minus 0.4t sine 20 is equal to 10g sine 30. I'm going to leave all the t's on the left hand side, so I have t cos 20 minus 0.4t sine 20 is equal to 10g sine 30 minus 4g cos 30. Now what we want to do is factorise out a t on the left, so you'll have t times cos 20 minus 0.4 sine 20, and that equals your 10g sine 30 minus 4g cos 30. And then all we can do then is divide across by that. So it is just a long old question, just to write it all down. That's going to be then 10g sine 30 minus 4g cos 30, all divided by cos of 20 minus 0.4 sine of 20. Fire that into your calculator, and I got 18.7 newtons to 3 sig figs. Okay, right. Figure 1 below shows two particles A and B attached to the ends of a light inextensible string which pass over a smooth fixed pulley. A has a mass m and B has a mass of 1.3, where m is less than 1.3. Okay, so that's your diagram. It says, so it's going upwards. Sorry, it's not. It's going downwards outside, because B is a heavier one, so it's going downwards this way. It's accelerating downwards this way. It's accelerating upwards this way. We don't need to do anything else at this stage to do the first part of the question. It says the particles are released. Initially, both particles are held with the string top, reading this bit here, sorry, at a height of 2.5 above the horizontal surface. The particles are released from rest, and B hits the horizontal surface with a speed of 4. So this is B we're looking at. It's released from rest. It goes down a distance of 2.5. It hits the ground with a speed of 4, and we want to find the acceleration. So you're just going to use v squared equals u squared plus 2as. V squared then would be 16. U squared would be 0. 2 times a times s would be 5a. So 16 divided by 5 equals your a. My a worked out to be 3.2 meters per second squared. Okay. Part B says for motion prior to this thing. So that just means before A hits the surface. Complete the diagram below showing the external forces acting. So A we didn't know, but it was mg. B we did know, it was 1.3, so g. And you're going to have a tension here going up. You've a tension here going up. It's going down this way, so it's moving. And we know what that acceleration was. We just worked that out to be 3.2. So if you know something, write it in. Just makes life a wee bit easier. And that's 3.2 meters per second squared going upwards. We're good to go. We're good to do that. Go. That's all the external forces. Find the value of this. So we're just going to say consider the whole system, and we're going to use F is equal to ma. Now the pulling force that's getting this going is a 1.3 g. Going against that is a t, but going for it's t, so you don't even need to write them in. But you've got mg, and that's equal to my mass, which is m plus 1.3 times my acceleration, which we know is 3.2. Fire that in and go from there. So that was just F equals ma, and then you just get cracking with that. I'm going to bring all my m's to the, well, I'm going to multiply out, first of all, the right-hand side here is going to be 3.2 m plus 4.16, and then over here, that's just going to be, well, just leave it as 1.3 times my g minus, I'll write that as 9.8 m, and then we can just fire that all in. Bring that all to one side. You're going to have 3.2m, or sorry, I'm bringing all the m's to the right hand side, and then I'll have 1.3 times my 9.8 minus a 4.16. Just to save me doing any working out, I'm doing minimal working out here on my calculator. When I add those two, I get bang on 13. I think I will just put that in my calculator. 13 times 1.3, sorry, times 9.8 minus 4.16 works out to be 8.58. And then 8.58 divided by 13 is equal to my m, and that worked out to be bang on 0.66 kilograms. Okay, right, what happens next then? After B hits the surface, A does not reach the pulley. Find the minimum value of D, correct in nearest centimetre, for which this is possible. Okay, right. Now what happens if we go back to this diagram? If we go back to this diagram here, we'll do for the music. Go back to this diagram here, what happens here? When this thing hits the ground, this is where they start originally. But when this hits the ground, B hits the ground, there it is, smack on the ground. If you imagine, the string actually goes slack, but also A has gone, that one's gone down 2.5 meters. This one's then gone up 2.5 meters. And then that string is slack. That means its movement is 100% to do with gravity. There's no tension pulling it up. So it's now on just moving under gravity. But it's already gone 2.5 up. Then you want to find the additional distance it can get to the pulley, basically. So we just have to add in a wee bit of working out here. The minimum value of D, and that is going to be, is if it just misses, I've said, or I could have said avoids, misses hitting the pulley. Okay, so it goes up here. If you imagine, once it goes there, that's still slack, that's still on the ground. This goes up and it just gets to here, but it doesn't actually hit. So it's gone up all that distance, and we want to find the minimum value of D. So what we want to do is find the height that it goes up. So remember, when B hit the ground, it was moving at a speed of 4. So that means A is going to be, my initial velocity for A is going to be 4 upwards. If it just comes to rest, so it just avoids hitting it, it comes to rest then. And the acceleration is completely to do with gravity, so it's minus 9.8. And we want to find that distance. So we're looking to find that distance there. So we're just going to say V squared equals U squared plus 2AS. So that's going to be 0 is equal to 16. 2 times minus 9.8 is minus 19.6S. 19.6S is equal to 16. Your S, the wee bit that you've gone up there, is going to be 16 divided by that, which worked out as 0.816 meters, 3 sig figs. But your answer then, the answer then is going to be 0.816 plus 2.5, which gave me 3.316 meters. 3 sig figs, wasn't it? So it's 3.32 meters to 3 sig figs. Okay, so remember, it had, if we look back, where is this diagram? You'd already gone up this. We had found that this was our 0.816, and you'd already gone the 2.5, so you want to add that on as well. Okay. Right, on to the dreaded statistics. Really not too nice this at all. So it says here, the cumulative frequency diagram in figure 2 below shows the ages and years of all runners who took part in a charity race. So you go from 0 up to 90, it looks like. For the data in the cumulative frequency diagram, show that the estimate of the mean age of runners is this. Okay, don't take this down just yet, but what we need to do is find your X and your F. And once you find that, you can find use your calculator, fire those values into the statistics function, and then find the mean. Okay, right. Now, this is where this is tricky. So I'm going to have age, and then I'm going to have, I'll do midpoint X, and then I'm going to have my CF column, which I can get, and then I'm going to have an F column. And it's this one and this one we're going to have to use, but we've a bit of work to do to get there. All right, so not easy to figure out what's going on, but once you've got this column and this column, it is very easy, but it's getting that, and unfortunately, the majority of people wouldn't have known how to get started this question. So the age, let's look at this. Now, here you can see from your table what this means here. That means there are less than 10 people that are between 0 and 15, sorry. So the age is 0, I'll just say, is less than or equal to your age. A is less than 15. And the cumulative frequency for that was, what have I just said? It was 10. Okay. The midpoint of that, from 0 to 15, add 0 and 15, divide by 2, you get 7.5. And the F then is 10. Okay. The next one, the CF, so there were 40 people that were less than 30. So 40 people here. And so that was then 15 is less than or age is less than or equal to 30. The midpoint of that would be 22.5. And then the F, to get this F, it's 40 minus 10. So that was the next 30 people. Now we go through all of that to get there. So let's just do all the ages first of all. So it was, next one's going to be 30 to 45, 45 to 60, 60 to 75, 75 to 90. We'll just put them in first. Okay, and then the corresponding value midpoints. So just adding the two extremes and divide by 2. And the cumulative frequencies, so just going back to all of those, the next one would have been this one, which was 84, then 110, 116, and 120. So they can put those in as the cumulative frequencies, and then we can work out the rest. So it was 40, 84, 110, 118, and 120. So the F's, to get the next F here, you would do 84 minus 30, which is, it's not 84 minus 30. It's 84 minus 40, which is going to be then 44. Then it's 110 minus 84, which is 26. And then 118 minus 110, which is 8. 120 minus 118, which is 2. Okay, now go to your stats mode. Let me see how I do this. On my ClassWiz calculator, I go to my statistics option, and then I go to variable, and then in my X column, I'm going to put all these values in, and then all these values in for my F. And then I go to my calculator, I go press AC, and then I press option, and I go to variable calculation, and then I can read off all the things. So I would just say from the calculator, we need to find estimate of the mean. So you need to get your sigma x, and I have done this earlier on. So I had got 4470, and then sigma x squared, 199350. My n, 120, and there were 120 runners. I think I told us that, did I? And then your x bar is 37.25. Okay, so you can see that's what we were looking for. So we know we've got our full marks there. That's great. Now the next thing asks you for the variance. Variance from your calculator is sigma squared, and it worked out as 273.6875. I don't think I'll take a mark off you if you don't do the next step here, but if you said then that's 274 to 3 sig figs. Okay. Oh, right. Outlier stuff then, still on this one. For this data, an outlier is defined as any value which falls outside the range. So where Q1 and this thing here, where Q1 and Q2 are values for the lower quartile. So we'll explain why there may not be any outliers for this data. Okay, we've got to find Q1 and Q2 first of all, and we're going to find that from the graph. So your Q1 is equal to your Q3, I should say. So we're going back to your graph, and I'm doing this very roughly here, but my Q1, I would go, there's 120 things, 120 values. My lower quartile end is going to go across at 30 and down. Now for me, that looks like it's 2/3. Every one of these wee boxes, there's 5 wee boxes between 15 and 30. So every wee box is worth 3. So that's nearly 2/3. So that's going to be 5 and then another 1. So that's going to be, as far as I can see, I think that's 26. My upper quartile, I think it was a bit easier. It seemed to be bang on this. So if we go down and see what my upper quartile was, 45, 48 then. So I've forgotten what I've just said. 26 and 48. Let me just check there. I've just done earlier on. Let's see if is that right? 26 and 48. Yep. So that means my Q3 minus Q1 then is going to be equal to, it's going to be 22. Now, let's calculate these things. So we'll see what they are. So Q1 minus 1.5 times Q3 minus Q1 then would be equal to, that's going to be 26 minus 1.5 times 22, which worked out for me to be minus 7. My upper one is Q3 plus 1.5 times Q3 minus Q1, which is 48 plus 1.5 times 22, which works out to be 81. Okay, so an outliers are outside minus 7 is less than or equal to your age is less than or equal to 81. Let's read the question again. Explain why there may not be any outliers in this data. Okay, there's no lower boundary. There's nobody going to be outside less than minus 7 years old. That doesn't make any sense. And we're talking about a fun run. It's highly unlikely that there's going to be somebody running greater than 81. Okay, so just say, so very unlikely. Anyone running greater than 81 years old. And if they are, fair play. Right, next one. Nasty wee Venn diagram, what is it? No, it's not. Nasty regression calculation. Okay. Right, it says here, as part of the appraisal process, 48 employees at a large firm were asked to rate their job satisfaction X on a scale of 1 to 10. For each employee, the number of days absent for work over the past year, Y, was noted. Summary statistics were calculated. So you've got this, calculate the product moment correlation coefficient for this data. So there were 48 things as well. So another wee bit of data we need is a number, and it was 48. So right, from your formula booklet, you can do this in one go on your calculator. I'm making that sound easy. This is not easy at all. It's very difficult to put in. So the formula is sigma xy minus sigma x sigma y. That's over n. That's all divided by, and it's the square root of this whole thing of sigma x squared minus, and it's sigma x, that bit is squared over n, and that's times sigma y squared minus sigma y, that bit's being squared, and that's over your n. So that's what you've got. Okay, you've got all of those values. You can put this in, and as I say, this is not easy, but your sigma xy is 4939 minus, and then bracket, so this is our top line of our fraction, Sigma x is 1099 times sigma y. Oh, sorry, sigma x, apologies, is 220 times 1099, and that's all over 48. Your bottom line is, so my sigma x squared is 1314 minus my sigma x, which was 220. It's being squared, it's being divided by 48, and that was times my sigma y squared, which was 33145, minus my sigma y, which was 1099. It was squared over 48. Now, I found that awkward to put that in my calculator. My calculator wasn't playing ball. So what I could do is split this into two roots. Root of this thing and then times root of this thing. It made it a wee bit easier if I put it in my calculator that way. And I did that, and I got r is equal to minus 0.0628 to 3 sig figs. Okay, so pretty close to zero. That indicates pretty much there's no correlation, and I think that's what they ask us next. Give an assumption and an interpretation, in context of the value obtained. So very little correlation. Okay, so that means there is very little relationship between the number, remember we're talking about job satisfaction and number of days off, so the number of days off, or days absent, I think they said, use their language, days absent, and job satisfaction. Okay, so that's quite a good thing for a company. So even if somebody's unhappy, they're still going into work, and if somebody is off work, they're not off work just because they're unhappy. They're just genuinely off work, so they're just genuinely sick. So that is it. Okay, so the personnel manager, next question, sorry, the personnel manager tries to find the equation for the regression line for the data. Her equation is this. Right, so on this, by the way, you shouldn't be doing, I think this is the very last part of the question, is there's no correlation. Basically, there's hardly any correlation, so they should never have been doing a regression line. So you can't force a relationship where there isn't one. So here, how can you tell there's an error in this equation? Right, so if you put a value in, and I'm going to put a value in which is y equals 0. Now, y was a number of days off, so if you put y equals 0, that means there's 0 days off. Let's just put that in and see what happens. So 0 would be equal to 2.8 plus 0.97x, which means minus 28 is equal to 0.97x, which means x works out to be minus 3.77. And our scale was from 0 to 10, was it? Or 1 to 10, I don't know. So basically, our equation does not work. This person's equation, sorry, does not work for someone has not been off, okay? Because their thing is off the scale, so it doesn't matter. It doesn't work, sorry, at all. Explain why a regression line would be inappropriate, and it's inappropriate because there is almost zero correlation. Okay. Right, next question. Almost there. It says, during the first 3 weeks of December, Amy runs a stall selling scented candles at the Christmas markets. She only accepts payments for payments by cash or card. In addition, they can also have their candle gift wrapped. So let's just write down what it gives us. It tells you of the 115 customers, so total is 115. It said 48 had their gift wrapped, so 48 had gift wrapped. 77 paid by card, so card was equal to 77. 3 customers, so we'll work out, sorry, we'll forget about that for the next wee bit. We'll work out the cash then, so either pay by card or cash. Cash then would be 115 minus 77. Cash then would be 38 people. okay? And we also know that it tells you cash, 3 people who paid by cash, cash but not gift wrapped was equal to 3. Okay, your Venn diagram, and there were so few people got this. So when I was talking to them, right, so we had, there was your card, and your card, it was card and gift wrap, so these things aren't even touching. So there's no overlap. So card and cash, there's no overlap with card and cash. And then weirdly then, you have another one here, which is this middle circle is for gift wrapped. Okay, so you've got gift, you've got card, and you've got cash. So it's a very weird Venn diagram. Now, the thing that I want to fill in first is this 3 people who paid by cash but didn't get a gift wrap. So if that's 3, then this one in here is how many people paid by cash in total was 38. So I've worked this one out by doing 38 minus 3, so that gives me 35. There's nobody in here. There's no one, you can't just get some gift wrap without paying for it, so there's actually 0 in there. Then you have got, you know that there are totals. So the next thing I'm doing then, you know there's a total of 48 people pay by, or get a gift wrap. So this is going to be 48 minus 35, that's going to give me 13. And then you know card was, there were 77 people, so 77 minus 13. So there's 64 people who didn't get it. There's gift wrapped. Question says, using a Venn diagram or otherwise, find a probability that a randomly selected customer had their candles gift wrapped and paid by card. So gift wrapped and card, we're looking for this thing. So we're looking for probability of card and gift wrapped. It was 13 over 115, and that to 3 sig figs. I don't know if they would want that. They'd probably happy enough with the fraction, but there we are, to 3 sig figs anyway. Okay, last bit says, Amy claims that about 2/3 of the customers paid by card. Explain how Amy arrived at this figure and why she may not be correct. Okay, so card, first of all, that's what we're looking for. She said 2/3. So card, there were a grand total of 77 people. You can see 64 plus 13, so 77, out of a total of 115, and that works out as 0.76, so that looks good. But why may she not be correct? So if you go back to the start of this question, if it lets me, it says, during the first 3 weeks, so 21 days of December, Amy runs a stall and sells scented candles, sandals, where was this? It mentions one Saturday. In addition to, where does it say this? Yeah, sorry. Amy served, of the 115 customers who Amy served one Saturday, so it's only one Saturday we're talking about here. So this is, she's right to think that there's 1/3 of the people pay by card, but that's only on that particular Saturday, one day out of 21. So I would just say this was only one Saturday. So not necessarily representative of the whole 3 weeks. Okay, something like that. So it's really an idea that what they're sort of testing is your understanding that a small sample doesn't always represent the whole population. That's it. Okay, right. People hated this question. Okay, it says the probability distribution for a discrete variable x is such that x is distributed with a binomial, and that is your n. So remember, x is distributed binomial np. So your n is 4. It says given that 9 times the probability of x is equal to 3 plus 4 times the probability of x equals 1, find the value of p. Okay, 9 times the probability of x equals 3 can be found by NC3 in this case, times your probability of success to the power of 3 times your probability of failure to the power of 1 is equal to 4 times your probability of getting 1. So N4C1 times P to the power of 1 times Q to the power of 3. Now, we need to then just do 4C3, you can do in your calculator, that's just 4. Then P cubed, and the Q is the same as 1 minus P. So it's either success or failure. So if P is the probability of success, failure is 1 minus P. Then 4C1 is also 4. And then that's P, and that's 1 minus P squared. Oops, not 1 minus P squared, it's 1 minus P cubed. Now, there's a lot can cancel. So nice neat line. Your 4's cancel first. I'm just going to write that out with that. So P 9 P cubed 1 minus P is equal to 4P 1 minus P cubed. And then what I can do is divide through by P and also 1 minus P. Yep, and 1 minus P. Okay, so that would give me 9P squared is equal to 4 1 minus P squared. And then we'll go from there. So that's 9P squared is equal to 4 times 1 minus P. Do this out. This is a very common thing for people to mess up. That's going to be 4 times, and that's going to be 1 minus 2P plus P squared. Multiply out 9P squared is equal to 4 minus 8P plus 4P squared. Bring it all to one side. You'll have 5P squared plus 8P minus 4 equals 0. And then my sum is 8. My product is minus 20, so my two numbers are minus 2 and 10. So 5P squared minus 2P plus 10P minus 4 equals 0. Factorize the first two terms, P comes out, leaving you 5P minus 2. Factorize the next two terms, 2 comes out, leaving you 5P minus 2 equals 0. So 5P minus 2 upon P plus 2 equals 0. This one means P equals minus 2, not possible. This one means P is equal to 2/5. So your answer, P is equal to 2/5, or, as a few people have said to me, 0.4. Okay, very tough paper, I thought. The mechanics was nice enough. The stats I thought was quite nasty, and I know a lot of people did struggle with that stats. So a couple unusual questions, especially that cumulative frequency one. I thought that was a fairly nasty question, and the Venn diagram just very unusual, and even this last one here, very unusual indeed.